Okay, welcome once again. So last time, if you remember, we were looking at the user interface, the front end, basically, and we talked about Next.js and React. But more importantly, we talked about the principles of building front end and the fact that the front end um, is an extension of the back end when it comes to building for AI, right? The front end becomes an extension of the back end. There are capabilities that you would have, at the front end, which will connect to what the back end has to offer. So we went through all of that in detail. Yeah, this was not really about me teaching us how to use JavaScript and all of that, but we'll do a bit of that today. Today we are going to essentially build the entire thing, right? Back end, front end, following all the principles that we have been talking about all of these weeks, right? So we'll just get to it, and it's pretty much so we don't have a lot of time, so I'm just going to kick off. We're essentially going to build a chat app, right? With a front end, um, streaming responses from the front end, memory, right? Tool enabled agent at the back end, RAG retrieval. Then we'll even include voice input and we'll do rate limiting and a bunch of other nice stuff, right? So this is kind of a lot to squeeze into a 2 hour time frame, but I really want to do this. Um, in order to help me, I've actually done some parts of it, but I didn't want to do everything. In fact, ideally, it would have been nice to start from scratch and build, and maybe even use a few AI coding tools to help generate. But we might have to do that along the line, right? But at the end of the day, I'm going to build something not from scratch, but as close to scratch as you could actually achieve in a 2 hour time frame. So it might actually stretch beyond the 2 hours, but we'll see where we land. All right, so that's really all we plan to do today. If we can get all that done, then maybe we can do a bunch of other things as well. All right, so the first thing I'll do is I already have a back end that was built, even though it's incomplete, right? So we'll complete it. I remember if you go to the lang chain, I have a lang chain. So I'm going to use code spaces, by the way. Code spaces allows us to have the same capabilities that VS Code gives us, right? But we do it in the browser. Of course, I could have just done it in my VS Code locally, but I want it to be easy to see and easy to share with others. So we start off with this, right? This is a lang chain example, sorry, lang serve example, which we had done previously, right? In this lang serve example, over a couple of hands-on sessions, we had continued to add stuff to it, right? I remember I also did a RAG, okay? I had a RAG setup as well, which I shared, but this RAG is in JavaScript. Let's see, I think I have it in my repo. So I have it in this repo. Let's see. I think I have it here. If I don't have it, yes. So I have it in this repo called Hybrid Retrieval, where I basically built it with TypeScript. Okay, so I have a hybrid retrieval, which I built with TypeScript. Um, Well, it's not just TypeScript. It's basically showing us how to do retrieval. I have both a Python version of it, right, and a TypeScript version. So I shared this. If I haven't shared this, I think I have shared this. So this is a full naive RAG implementation using LangChain, right? So there's a Python version and there is also a TypeScript version. So pick the one that you like. They both actually do exactly the same thing, and we can run through it. So with this, I don't really need to build the whole backend. Okay, I'm just going to open. Um, I think I have an existing code space, but I'm going to open a code space with this. I'm going to open a code space, so I can run any of these two, right? If I want to run it with Python, I use UVcorn. If I want to run this with Node.js, I just run Node.js. But yeah, you can see here, what does this rag do? Um, so this rag, I use Pinecone. So I'm using Pinecone. So I'm going to create a Pinecone. This is not connected to Pinecone yet, since it was just a demo code. And it has a bunch of things. So it has a document splitter, right? And right now the document splitter uses a very basic recursive character text splitter. There are a bunch of other splitting approaches you can use. And there are a bunch of other ways you can improve on this, right? So we'll have a document splitter. But you pass in the file path that you want to split. So here you could split just a single file, and it splits the document in that file and gives you the chunks, right? Then I have a bunch of vector store builders here, depending on which one. So I made it so I could choose. So I have a Files vector store builder using LangChain OpenAI embeddings. If I don't specify the embedding already, it will create OpenAI embedding with the OpenAI API key. Then I have a Chroma vector store as well, right? I have a Pinecone vector store as well, right? This connects to Pinecone. It gets a Pinecone index. So I will have to create a Pinecone index and then pass that in as an environment variable. Then that's the second bit. There are a bunch of others as well, like Weaviate and so on, but I didn't bother trying to create. We can create if you want. Then format docs. This is just a way to format the document before you send it to the LLM, the RAG context document. So then I have the class that does the uploading part. So remember, in a RAG, you have two parts to it. The part where you upload documents and the part where the uploaded documents, you use them as context. So this class just handles uploading. Um, so we create a Hugging Face embedding, right? I basically just chose to use Hugging Face embedding. But if you can still pass in an embedding, right? So you could use OpenAI embedding or any other one, right? If you pass an embedding, it will use that. If you don't pass, it will use a Hugging Face embedding using the sentence transformer all mini LM, right? So that's what it uses. I need to even change this because it should have the full thing. Then, yeah, we specify which vector store type we want to use. So by default is Chroma. But you could use any other one. So this is where I will now, then a text splitter will create a new recursive character text splitter. And then the vector store is none. Then the list of documents, and then we have a retriever. So here we are boosting our retriever by adding what we call a BM25. So let me take a while to explain what a BM25 is. Is best match 25. Basically, it's an algorithm, right, that you use for ranking, right? It's what we call a best match 25 or best matching 25. So this is a keyword ranking algorithm. So what happens is that when you are searching in a database, you pass in keywords. That's typically what we do with um, the conventional databases that we have. So you find the best matching 25, right? It's used for a lot of search engines, and of course, it's used with RAGs. I'll explain how it is used with RAGs. But typically, what you do is you you give keywords. The algorithm checks how many times that those keywords appear in a document, right? It uses some kind of function, saturation function, and so on. Saturation function means if it is, if it happens, for example, 100 times, it doesn't mean that it's 100 times better, and so on. So, but at the end of the day, it pulls out the best matches, right, based on that algorithm. So, LangChain has a built-in BM25 algorithm, right? BM25 keyword matcher, and you can create a retriever from it. So we this is a variable that holds the instance of it. So what happens is when you want to um upload a document, right? There are various steps. So this is the first initialization, but there are a bunch of things you need to do, and there are a bunch of functions that we have created to do that. When you are setting up this RAG document uploader, the first thing is this allows you to add documents, right, to the indexing system. So if you have already created an index, you can add more documents to it, right? Right now, the documents are stored as a list. Okay, this is just for a simple implementation, so you can see. And the list is a list of document objects. LangChain has a, you know, a, a, a type, a type or a class it defines that, you know, kind of represents documents basically. So it's called a document type or a document object. So all the documents are stored in a list. So when I want to I can add a new document to this list of documents, right? Using this add documents function. So all it just does is it extends. If you have another bunch of documents, it extends the existing list and adds all the documents in this list to that, right? And then it prints a message. Then, if you want to load a new document, you pass in the file path to that new document, right? And what it does is it's going to, this file path can contain a lot of documents or a single document. Well, it's going to really load only a single document. And it's going to chunk it into LangChain documents. So it supports different types. Right now, we implemented text, PDF, CSV, which we have done before. Remember, there was even a long ago hands-on where I demonstrated this, right? But I didn't use LangChain. I basically did it with PyPDF and so on, right? But here we use LangChain. So this loads the document, it checks the file path, right? If that file path exists. And after checking the file path, right, the next thing it does is if it doesn't exist, it throws an error. If it exists, it's going to check the extension, and from the extension, it will determine the file type. So we have different LangChain document loaders, right, which depend on the file type. And a document loader in LangChain is a loader. Basically, these are classes of utilities that are provided by the LangChain community. You see that a bunch of them come from the community. So these LangChain community document loaders, they all come from here. But the default loader, the text loader, comes from LangChain core, even though here it still comes from LangChain community. So anyway, on the JavaScript version, this actually comes from text loader comes from LangChain core. I don't know why we have that difference, but we do. So to load a document, you determine which loader you would use. A text loader is basically going to consume everything as text, right? A PDF loader will use PyPDF, right? And load it. PDF has document structure, so that matters as well. CSV is going to look at the file as a CSV, comma separated values. It's going to have rows and columns, right? So it's going to be able to load CSV files in that row and column format. A docx, this is a Office, Microsoft, the universal document format. So this will load that. We also have for PowerPoint documents, right? Slides. We also have a loader for that. So depending on the document type, if it doesn't know any of this, it will tell it doesn't know that format. So once you load from the loader, then you pass that into the splitter. So we only have a single recursive text splitter, which will split. So the benefit of using these kinds of loaders is you can load different kinds of documents. It knows how to pass the files. And then you split the resulting document using splitter. There are other kinds of splitter as well. This one is just splitting based on text, but there are other splitters that may split based on the document model, right? For example, a markdown splitter may be based on the hierarchy, a HTML splitter, and so on. All right, so you split the documents into chunks. So you're going to have a bunch of chunks. Each chunk is a long chain document. That's what load document does. I've already talked about add documents. So if you want to stack more, then building a vector store. So depending on the type of vector store type, we will call this. So remember, I had already shown you three different implementations of vector store. So we have, so you basically call on the correct implementation. You pass in the documents. So when the vector store is built, it will populate it with those documents that have been loaded already, right? If you don't load, it will not build a vector store. So we should load documents first, and then you build a vector store. The embeddings, this is the embedding model that's going to do the embedding of the documents that you want to load, right? And that's it. So with that, I'm going to come to this retriever part of it. So uploading and indexing, upload a document index immediately is made up of the steps you load the document, right? And that gives you a list of documents. You add the documents, right, to the already existing list of documents. The chunked that by the way, what comes here is the chunks, right? And then you add those to the list of chunks, and then you run build vector store, right? Build vector store is going to basically create a vector store from those documents that you have uploaded. Then we'll build a retriever. So I'm going to talk about the retriever and the BM25, which we already looked at. Now, that is for a single file path you want to upload an index. But here, if you have multiple file paths, right, multiple files, you can upload all of those. So in that case, it basically loads each document, chunks it, and then adds it. So you have a way of loading from multiple places, multiple files. But at the end of the day, you still accumulate all the documents, and then you now still call on the build vector store, and then you build the retriever. Okay, so let's talk about retrievers. In LangChain, when you are doing RAGs with LangChain has this general concept of a retriever, right? So a retriever is essentially something that pulls documents from somewhere, right? Okay. That's the generic, that's the generic, um, that's how they think about it, right? They think about it in terms of that's how general they think about it. They're not thinking about documents per se, even though there's a concept of documents, but they are thinking of things as retrievers. They're not even thinking about vector stores, okay? But they're thinking about retrievers. So in LangChain, a retriever is a something that basically retrieves, and you have multiple ideas of retrievers. It's not just only from documents. You can retrieve from the web, okay? You can retrieve from um you know what makes a retriever is that it can retrieve data from anywhere. So you can retrieve from an API call, from an API. You can retrieve from a database. You can retrieve from web. You can retrieve from documents. So that's the level at which LangChain interacts, right? But the interesting thing is that LangChain allows you to be able to convert a vector store into a retriever, right? So that's how LangChain has kind of um, abstracted it, right? So for you to get a retriever, um, Let's talk about a BM25 retriever first. So you you create a BM25 retriever by taking all the documents and passing it into this class. So LangChain has this BM25 retriever class, which uses a BM25 algorithm I just talked about, the best matching 25, right? So what happens is the BM25 retriever is from the LangChain community. It uses keyword search, right? So you specify all the documents that it will search, which is basically a list of LangChain documents. And then you specify the top K. The top K here, K is 5. Okay. So that's all. You just do this and you build a BM25 retriever. So when we say hybrid retrieval, because I did this to explain the concept of hybrid retrieval, which was part of the requirements in the task that we ask that I have asked us to do. Right. Hybrid retrieval is retrieval where you combine semantic retrieval with keyword retrieval. So what's the benefit of hybrid retrieval? When you use semantic retrieval, yes, you can retrieve things that are close to what um close in terms of semantic meaning to what the user is asking for. But sometimes semantic retrieval may miss out some things. So there is that has been something that's been identified. So the solution to that is combine, you do semantic retrieval, and then you also search based on keywords, and you combine those two search results, and from there you can get your top whatever, right? That is what is hybrid retrieval. So when you're doing hybrid retrieval, you're going to use a vector store semantic retrieval, but you combine it with a BM25 retrieval. So in this case, we're using BM25 to provide us with the keyword search. Okay. So when you want to do the ultimate retriever, the hybrid retriever we are getting here is made up of two retrievers. You first of all get a vector store retriever, and then you get a BM25 retriever, right? So if there is no vector store, you first of all build the vector store. If there's no BM25 retriever, you first of all build a BM25 retriever. And if the retriever type that we want to retrieve, okay, is hybrid, you take the vector store which you have already built and you get a retriever from it. That's what I was saying, that LangChain allows you to get a retriever from a vector store. So what is the concept of retriever in LangChain? It's something that pulls something, but because LangChain is, it operates based on this chaining approach, right? A retriever, you can chain a retriever into an LLM and it works. You don't need to do any additional work to it. It's already configured, so you just chain it. So that's why you normally will have to um, get the retriever that connects to this vector store. Or the other way you could see it is I'm converting the vector store into a retriever, but that's not really what you are doing. What you are doing is you are getting a retriever, you know, that is tied to this vector store. So we get a retriever and we specify the K for the search, right? The K, we want K of 2 in this case, but we could specify K of 5. So we use K of 2 for the vector retriever, and then um, we now create what we call an ensemble retriever. So this is how you combine the two retrievers to make a hybrid retrieval. You use an ensemble retriever class. An ensemble retriever is a class based on an ensemble algorithm, right? That LangChain provides in LangChain Classic. So that ensemble algorithm, the way it works is that, like I said, when you want to retrieve, you're going to give it a list of retrievers, and it's going to apply each of those retrievers. You give it a keyword, okay? Give it a keyword. It's going to basically or give it not keywords. You give it the prompt, right? It's going to use semantic matching. Basically, it's going to pass that prompt as an input to these the two retrievers in this case, or whatever number of retrievers you pass in here. So the BM25 will take the prompt and take it as keywords. It will basically do keyword search on the same document database. The vector retriever will take that prompt and use embeddings to pull out vector embeddings to pull out the matching results based on semantic search, cosine similarity, or whatever else. And then the ensemble is going to basically assemble the results from these two. So you find that these two different retrievers may give you two different results, okay? But you now assemble them, and you use this weighting to determine, how you weight the results based on this. So the weighting here, you can see that the weights have to be passed in, right? And you see by default, it's a tuple of 0.5, 0.5. So you have 50-50 weighting for each of them. So the BM25 is going to get 50% weighting, and vector retriever is going to get 50%. You can tweak that percentage. So if you want a hybrid retriever, it's going to give you an ensemble retriever. But if you don't want a hybrid retriever, you can say, okay, I want a vector retriever. It's going to give you this vector store as a retriever with K as 5. If you want a BM25 retriever, it's going to give a BM25. If you don't specify anything else, or if you specify something else different, it tell you it doesn't know the type of retriever you're looking for. So a retriever is a concept in LangChain that allows you to you chain the retriever to the query, you chain that query to, you chain a query to the retriever to the LLM, right? And that gives you a full chain. So that's how you get the retriever. So now we've defined our document uploader. So you can see we now have uploading and we have retrieval. I don't need anything else for retrieval except this get retriever function. Okay, right. So if I want to upload, okay, we have some choices of different providers. This is just here to decide, okay, which provider should I use for embedding? So we choose Hugging Face. Which provider should I use for vector store? We use Chroma. So this is like presets, which you can change later on. So we initialize the RAG document uploader. We give it a vector store type. We want the vector store choice here. We specify Chroma. So we want Chroma. So we're going to use Chroma in this case, not Pinecone or FICE. Chunk size 500, chunk overlap 50. So we pass that in. So with this, we have created our uploader. So anytime I want to upload a file, we call on the uploader, upload an index, right? It does that. Okay. And that's just how we do upload. But if we have multiple files that I want to upload, so remember, then we can use the batch, the upload batch if we want to upload multiple files. So that's just it. If I wanted to use this with an endpoint, then I would create an endpoint, okay, and we can have documents stored, and then we can create a vector store. Now, the question I'm asking, and you would ask here, would be, what if I want to add new documents? So we would add using the document add, and then after we've add, we would rebuild the vector store, based on that. So that's how we would do that. That may not be the most efficient way anyway, but that's how we would do that. So upload an index, upload an index. So this is if the file exists. If it doesn't, then you can you have a message that's printed back. And then here, this is kind of a fallback to create a testing file in case there's no actual file. This is just for the purpose of testing that we are doing here. Then with that, if I want to get document summary, right, you call on this function uploaded or get document summary, which will tell you the summary of index documents, total documents that are in that uploader, the vector store type we are using, embedding model, and all of that. Okay. Then when you now want to you want to query, right? So this is an example of a user query, right? So this is the question. You can then create a retriever, get a retriever based on what retriever we want. And then you create an LLM. In this case, we're using OpenAI. You create a prompt template, right? And then you just chain all of them. So this is the benefit of using LangChain. I don't even need to do anything more. And that's the essence of a retriever, because with LangChain, you just use a retriever. And the interesting thing with retrievers is I could use something else as a retriever. I could get a web-based retriever and so on. So yeah, you get a retriever, you specify the context. The context um would be take the retriever, pass it through format docs. So remember, format docs is a function. In LangChain, Python functions are considered as chainable. So you can also chain that. So you see where we define this function. And what it does is it takes the document list and it joins the content with two new lines. So that's the first thing we would do when we are chaining that. We use a LangChain LCEL syntax. We pass this document, so that we pass the document through the retriever, or rather we pass the retriever, which will retrieve all of the um, matching, you know, the things that match to that prompt. That is what we use as a context. We pass it through format docs. That provides a context. Then the question is a runnable pass-through. Runnable pass-through allows this question to be passed through into the prompt template. So this is the prompt template, which is just setting it up and saying, we have the prompt template. It's actually a template up here. It says UI helpful AI assistant. Below is a user question and a relevant context. So remember, this context is a placeholder which we get from the retriever, right? And the question, of course, is a question which we also get from the user. So that's from the runnable. So this is how that assembles it. And then this is chained into the LLM. And then we can invoke it. We invoke the chain. So a RAG is basically a chain, right? That's that from LangChain standpoint, a RAG is a chain where you chain all of these things together. This is a TypeScript implementation of exactly the same thing, right? So you have all of the OpenAI keys, API keys, and so on. The prompt template is still there. We now have splitting of the document files. A text loader is used in this case, right, to split the documents. But you could use any other bunch of loaders. So apart from the text loader, we also have a PDF loader, PPTX loader, and so on. Right. Then you have the vector store. So we have three again. We can build a files vector store, right? We use this HNSW to build from documents. Then we also have a chroma vector store where you can bring in the chroma and from documents, and we specify the collection name. In chroma, you have to give it a name. And then Pinecone, for Pinecone, you create a new Pinecone connection. You put in the index name, so you get a reference to the index, and you use that to also generate Pinecone vector store. So that's basically the same thing. Format docs does the same thing here, right, as it did over there. Then we now have a document summary, which allows us to interface with the indexing system. The RAG document uploader, basically the same thing implemented here with TypeScript. The constructor, you have embeddings. If the embeddings is passing, you use that one. Otherwise, you use a Hugging Face. With Hugging Face, we use Zenova, not sentence transformers, because I think sentence transformer has a bit of challenges in JavaScript. Vector store type, text splitter, vector store, load document, same thing. You look at a document type, you choose a loader based on the document type. So you have a text loader, PDF loader, CSV loader, docx, and the PowerPoint PPTX loader. Then you split the docs based on that. Then you can add documents as well. Then you build a vector store depending on the type. If it's Pinecone, we call the Pinecone one, and so on, files and chroma. Then we also have a BM25 retriever, which we also get from the BM25 retriever class as well. And we build it from the documents. So you see that there's uniformity between the LangChain implementation on Python and in TypeScript. Okay, so same thing here, upload and index, essentially the same thing. Upload batch, this is now batch upload from multiple file paths. At the end of the day, you still need to build the vector store and the retriever. So get retriever does the same thing. You choose whether you want a hybrid and then specify the weights. So if it's hybrid, we will use we'll get the vector store as retriever. Um, right now, so the thing here is that here we don't have the ensemble retriever in the JavaScript TypeScript side, unfortunately. So we would have to use a custom implementation that will combine both, right? In Python, there's an ensemble. I'll check that and see what we can do with that. So for here, I just basically return the vector store retriever in this case. Um, yeah, but if it's vector, BM25 is still there, so you can use that document summary and you have a bunch of stuff. So same thing. Um, you you load to upload, you load from a file path, you use upload and index. If there's no file path, we created this default thing just for us to use. And then document summary. Um, then with the query that the user wants to query, then you have a retriever. So you use the get retriever here. You use chat OpenAI, and then we create a prompt template from that template. And then we do use the LCL syntax. We create a chain. We pipe the LLM. This is just the LLM only, but we could also have piped in the runnable pass-through and then the prompt template and the LLM. So at the end of the day, we do this. So it's the same thing, slightly different. The LCL is a bit different, for JavaScript or TypeScript. So this is a backend, right? Now, front end, I already did a bit of stuff on the front end, which I can show you my implementation, which I did with VS Code, right? Um, and you recognize that. So I'm going to do this because this is um and for this I might need to share my sound. Okay, so I'm actually going to start the project, but I have already done a bit. The user interface I have kind of already done, so that I don't waste too much time on it. So I'm going to push this to a repo, right? And um, I didn't push it before, but I'm going to push it now. And then I'm going to open it, right? So I have a code space. So I'm going to put everything into the same place. So even though I have a place here for I have a place here where I did lang serve examples, um, and I have another one, for hybrid retrieval. Um, I am going to do this particular thing in a new repo, and I'm going to pull bits and pieces of these, right, to use over there. Okay. And I'm going to do the back end I'm going to do the back end with Fast API and LangServe, and I'm going to do the front end with um with of course with Next.js, just very simple Next.js implementation. So and I'm going to put the two of them in a single mono repo, which might be difficult to do because I am essentially going to combine, but we'll go ahead and do it. So let's let's get started. Um, so I'm going to create a new repo and um, I will just create a new repo called rag. Um, so remember the task, full hands-on UI, right? Um, let's just say UI lab. Let me call it UI lab. And I have 1 hour left, right? Okay, so I will create a code space for this. So I can easily just do this. in- So I have a bunch of things that I did, which I am going to share as a starting point for this. So there is one aspect of this I also want to talk about. In this task, we are going to include voice input. So let's play around a little bit with voice input, right? And I have some experiments I already did, which I will just bring in here instead of starting from scratch. So yeah, in order to make this really work well, I'm going to base it on Next.js. So for me to create a Next.js app, I will there is what we call npx create next app. Okay. So I'm just going to run that here, npx. I'm assuming npx exists. Npx is the node package manager executor. It actually executes stuff, right? Um, so it is here, right? So I will just do npx create next app. Okay. I hope that will give me what I want. Yes, so create next app is going to create a Next.js app, and I'll say yes. So it's going to create a folder in here, right? What is your project named? So I'm just going to call it um UI um UI lab. Well, we can call it whatever I want to call it, but let me call it front end. Yeah, let me just call it front end because it's already UI lab, even though I don't know if that's going to be the name of the folder, but well, I don't know. Um yeah, let's just call it UI lab. All right. So we can we can customize things later on. Okay, so yes, use recommended defaults. So I'm just going to say yes. So it's already going to install dependencies, Next.js, React DOM, and then it also installs the Tailwind as part of it. Types, Node.js types. These are dev dependencies I only need for development. So you can see, of course, it has created that folder. I guess that's where I was hesitant, trying to figure out whether this UI lab will be only for creating the folder name or whether it will be used for other things, right? So for example, we have a README here. It's probably going to have UI lab in there or something. Yeah, but I can always change this name later on to front end, which is what I want to call it, and all of that. So anyway, it's doing a bunch of stuff. Um, so it's done that. It's installed the development dependencies, dev dependencies, the typing, which is needed for TypeScript, as well as Tailwind for CSS, ESLint, and all of that. So, and then 57 packages, node modules is in here. And so this is that. So I'm going to change this because I want to call this front end. So I'm going to change that to front end. Okay. Now, right. One thing I will need to do here is if I do a git status, so we have front end, so that's okay. Um, Node module should not be part of what I add. So I'm going to put a git ignore um, in here in front end. So change directory to front end. If I do a git status, then let's add a git ignore. Um, so I can just touch, I like to do command line. So touch git ignore is going to create the file and I'll see it in here shortly. If I don't see it, I refresh. Um, okay. Um, okay. Perhaps I'm surprised that it is not here in the front end folder. Okay. Mm, okay, it's here. I don't know. Maybe I didn't see. Oh, there's already a git ignore. Okay, so touch basically creates it if it doesn't exist, but if it exists, it doesn't do anything. Well, it changes the date modified. So node module is already in there, so I guess I'm good. Create next app actually creates a git ignore that is very okay for Next.js. So that's the first step. Now I want to do a bit of just playing around a little bit. So like I was explaining in the class when I did a little bit of explanation on Node.js and Next.js, I mentioned that Next.js creates for you a very rudimentary basic file structure, right? Where you can put, so you have this app, then you have API chat route, then you have a chat page, and then you have components. So we can kind of already follow that. We can already follow that here. So you see that front end, it has an app. Then in the app, you have page.tsx and a bunch of stuff, right? They have public contains things that are seen by the public. Node modules are the modules that are required for it to run. Think of this as your VM for those who are Python folks. Think of node modules as your VM where all the dependencies are installed. So in Python, they are installed in your VM or whatever name you call it. But in React and Vue and all the rest, it's stored in node modules, right? And this name is fixed. You can't change it, unlike VM where you can name it anything you like. So that's where then the .next contains compiled files which will be served. Here right now we have type information for TypeScript. So app is where our app is, right? And page.tsx contains the home page. So right now, I can actually just deploy this. In the package.json, you have dev and you have build and you have start, right? So I can run dev, I can run build, I can run start, right? Run start is how you run it in production. Run dev is when you are in development mode. So I think I could run dev, right? And then yeah, so let me open another terminal. And to run dev, you could do npm run dev. Okay. Um, okay. Let's see. No such file, package.json. Okay. Okay, I have to be in a folder, so I have to be in the front end folder. Okay, I was not in the, you have to be in a folder that has a package.json. So I can now run dev. So it's going to switch into dev mode and it's going to open this. And there is also another port that is open on the network. That port is available, right? I can go to ports here and make this port is private now. I make it public, right? I make it public. So it is now public and I can access it through this link. So I'm just going to copy this link and then I'll open another tab here so that we can see how it looks like. And yeah. So of course this is a normal warning, so continue. Yes, so you see Next.js, because I didn't do anything, this is Next.js default page, right? So yeah, so this is not what I want people to see. So I'm going to change that default page is in this page.tsx, right? So I can always change it to something else that I want, right? So for now, I'm not going to throw away this page.tsx. I'm just going to rename it to something else, maybe old page or something. So Next.js will not see it. Um, yeah, no, I'm not going to update. So if you come here now, it's already showing you a 404, meaning that yeah, I that page doesn't exist. Okay, so I am now going to make a new page.tsx, right? And I'm going to use a bunch in order to speed things up. I'm going to use my agent, I'm going to supervise it and use my agent to do a bunch of stuff for me. But first of all, I'm going to create page.tsx. Okay. Um, this one is an empty one. I'm going to put in my stuff. So right now, I had already created this. Okay. This is not a TSX file. So you see all of these errors because I am not doing a TSX file. Typically, if you have layout like this, you normally put in a layout.tsx. Okay. Now you can see that the layout in JavaScript in Next.js rather, Next.js, the page contains the actual page content, and this should actually be a component, a React component, right? But I just dumped in HTML. That's why I'm getting all of these reds, basically telling me, hey, you're not supposed to dump, your crappy HTML in here. You're supposed to dump an actual class, right? But I have stuff in here which I'm going to move around. Maybe I can ask my agent to do it, but I'll do it myself. Um, but you dump HTML normally in this layout class where you can put stuff in here, right? And there's already a default setup here which comes with Next.js. So what I will do is um, I don't feel like using the agents now so that I don't make things unnecessarily complex, but I will rather comment out this and then I'll dump my own HTML in here. Okay, so I've dumped my own HTML. So this is the correct place to dump HTML. But you will see that there's a bunch of other stuff here which is not supposed to be part of the layout. As the name implies, this layout is supposed to be just for your layout. Okay, not yeah, just for your layout. And let's see. So I'm trying to indent it correctly. So doc type is not part of layout. Next.js will add that for me automatically. So I take that one off. So I'm left with HTML. Language is English, right? That's what this means. So I'm good with that. The head also, there's a body in what was here before, but I have a head, right? I don't know if I need to keep the head, right? But that's okay. Then we have the style. Um, I think I'll keep the style as well, even though ideally this is not the correct way to do all of these things. Style should be put elsewhere, but I'll leave this in for now. And then I have the body, right? And if you look at the original implementation, we had body. So first of all, we have global CSS. So all the CSS should be moved out. Maybe I should use my agent to help me do this now, um, so that I don't need to worry too much. But there's this whole section of it which, um, in fact, let me ask the agent to do this, right? I have an empty, so this is the prompt. I have an empty page.tsx and I dumped raw HTML into this layout.tsx. I want you to reorganize this following next.js pattern. Move the components code into a page component in page.tsx. Yeah, you can create sub components as required. Do not change any functionality. All right, so this is Copilot. I put in agent mode. It knows the context. The context is layout.tsx, which is I just dumped all of this and then I asked it to clean it up for me. So let's go. So while the agent is doing all of that nice stuff, um, we are going to do something as well on the back end. So I'm going to copy another file, right? I had some stuff I had here, so I'm just going to copy them and put in a new file. And I'll still add the agent to do all of that. So let me create a new file in here. And I call this recog.html. So the experiments I did was in raw HTML. It wasn't in Next.js or anything, right? And so I'm going to create another one. I call it synth.html. So these were experiments that I did with speech synthesis and recognition. Okay, and I did them in raw HTML files, which we can also do here. I'm going to play around with this, right? Because these are all ready. Okay. Now this is I'm going to create another one here called synth.js. Okay. So the thing is, so this is speech synthesis. I think I mentioned something like this a bit. Okay, which is speech synthesis. This is how you do synthesis, right? Or you use this speech synthesis utterance class. Okay, so speech synthesis utterance class allows us to be able to synthesize speech, right? While you can also be watching the reasoning of our agent as it is doing stuff. So you can check the reasoning. I actually take some time to look at its reasoning. Let me start by reading this, an empty page, raw HTML. They want me to do this, do that, you know. So that's the first reasoning. And then second one, it tells you what it's doing. Let me read more of the layout. Now I understand the situation. Layout has raw HTML, blah, 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 restore layout. So all nice. So it's interesting to look at the reasoning of the agent and read it sometimes. Okay, so this is the one that it's currently generating as it is solving your problem. It's created 3 to do. So this is a case of um plan and execute. So remember we talked about 2 types of agentic reasoning loops. We had the react loop and the plan execute loop. You can see it doing plan execute here. So the Copilot agent actually does plan execute. These 3 to-dos are the plan, the 3 steps in the plan, right? So after the 3 steps, it doesn't show me the to-do. I notice it doesn't do that, right? For some reason, I can't find the to-dos, right? But it says it has created 3 to-dos. So that's the planning step. It's done the 3 plans. Then it starts implementing them, right? So starting step 1 is layout, restore layout TSX, That's step one. So you see 1/3. Okay. And it does all of that. When it's done, it tells you the second one, starting create page component with chat interface 2/3. Okay. And it tells you how it's doing that. It creates subcomponents as well, which is pretty nice. I didn't know it was smart enough to create subcomponents, but it does because everything was just, banged up into one single HTML file. So it creates subcomponents, header component, message. By the way, it's taking this based on the input I gave to it, the raw HTML I gave to it, and it's done that. So it now it tells it's completed the step 2, and I think it's done the step 3. So files have been reorganized, and then it finishes and it tells you done. So again, this is something for us to learn, right? This whole transparency thing we talked about. See how transparent it is, telling you everything it's doing. And at the end of the day, it gives you a summary of what it has done. So this is the principle of transparency when you're talking about building AI agents. So I always watch Copilot as a way to kind of validate some of these principles and also learn. So anyway, that was that. Okay, it's done anyway. So let's look at what it has done before we go back to this. One other principle is this idea of approval, human in the loop. See, even though it has done the changes, it's actually done the changes. So if you were to print this layout.tsx from the terminal, for example, here, yeah, meanwhile, my whole thing is getting heartburn because I dumped very bad HTML. It was having heartburn, but because the agent has fixed it, it's now back to a check. Anyway, so let's go back to this. You can actually print the layout.tsx, right? You can cut layout, app layout, and you see that it has cleaned up the app. The HTML is just back down to the original Next.js HTML, right? That's what is actually in the file. But here, what the builders, the developers of VS Code and Copilot have done is they still show you what it was before, right? And they now give you this button, keep or undo. So this is a human in the loop. This is approval, even though it has already done it, but this is a kind of post action, still asking you if you want to keep it, you keep. If you don't want it, you can then click on undo. So this is another principle of human in the loop, which this is very well, demonstrated here. So I keep, right? And every single change, it brings it up and tells you. So here you have a page.tsx where all of the stuff has been added. And we are seeing use client in page.tsx, which I think that should be a problem, but I don't know. Um, okay, because we're not doing static page. So everything I had in the HTML, which is a lot of stuff, it is now in here. I'll probably still come and clean this up later on. Okay, so it's created the layout.tsx, it's created a page.tsx. If I now go to page.tsx, refresh, we had default export is not a React component on page. I don't know why it says that. Okay, so we now have our messaging interface, which I built before now, except I built it as HTML. So I've converted it to a React. So I need to update. I'm going to update this. Anyway, so now let's look at synth.html. So I already have synth.html. This is for voice speech synthesis. And I have a synth.js JavaScript. So while I'm going to explain this JS, I'm also going to tell my agent to convert this into a React component as well and put it in synth.jsx. Put in synth folder synth/page.jsx. Okay, convert this into a Next.js page in a synth/page.jsx. You could still you may not be this detailed and it can still make choices for you, right? And fit it into the existing file structure. Okay. Generate sub components as appropriate. Reuse existing sub components, existing components if available. Okay, so it's going to run this. So while it's running that, let's talk about voice synthesis. So speech synthesis and speech recognition are two of the key elements, right? If you are building something that's you want to be able to communicate with people. So this is how you would do it typically, right? You have this class. Okay, you have this class called, let me hide this. So you have this class, this utterance, speech utterance, right? Which is built in. In Chrome, you have it, so you don't even need to import it. So you create an utterance. When you create an utterance, there you can set properties for the utterance. So for example, the pitch, right? You can set the rate, which is how fast, the speech is synthesized. You can also set the volume. Okay. So what I did was in this situation, I specified what something is a thing that is to be said. In other words, the words in text form. Then options are additional options, which if I want to tweak it from a user interface, right, I can tweak it. Okay. So options allow me to tweak it. So if the pitch is specified in options, I'll use what is specified in options. If not, I'll go to a default of 1. So that's what this does. Same thing with utterance. Use what is specified in the options, or you default to 1, and so on. So that allows it's always a good idea to do stuff like this because it means you have a fallback, right? Oh, by the way, so this is another human in the loop thing, right? It wants to run build to confirm that everything is working fine. And it asks for my permission because running command line scripts is something that requires a human approval. Otherwise, something will go wrong. And so it needs your approval. So I clicked on approve to allow it. Then they see the keep, which is another human in the loop. So you see that there are two different types of human in the loop now. The first one required my approval before it runs the command. So for critical things, always do it that way. But this one asks for my consent after it has done the thing, right? Because it's not critical and it is what's the word? Is reversible. This is reversible, but the command may not be reversible. That is why it is asking for your. So I'm still going to keep the file changes. The file changes are in here, right? So you have AppSynth and page.jsx. So all of this has been done, right? Which is, I'm going to explain this shortly after I finish explaining this. So meanwhile, yes, it created the new synth in the synth folder, right? Components and page. And then it even moved we have the synth.js in here, right? Which is interesting. But I'm actually going to move this in here. But it didn't touch this. It didn't touch this either. So it kind of retained what was there before while creating new ones. But let's finish and then we'll tidy up everything. Okay. I'll also go look at what it did. Right. So I was trying to explain voice synthesis and the different parameters you can set. So when you have done that, you could even have voice names. So here you have where I can select a list of voices, right? And we'll see that in demo. And then when we select the list of voices, you can now call on speech synthesis speak. It will speak whatever you had passed in based on these settings, right? And that's how speech synthesis works. Um, then this is speech recognition. So recognition does the same thing, right? Recognition uses the recognition. So in this case, I had a button where it will recognize what you say. Like this one requires microphone access. We are going to essentially rework this. But let's look at speech. So my agent has generated and it has even created all of this. I did not go into the components folder, but it has. So it obviously took the synth.js here, which we just looked at, and it basically imports get default get available voices from this, right? Maybe because so it creates a bunch of components. So what we had before, all of the components were thrown into one place. And we are going to look at the components. But we had a bunch of components here. Let me show you what we have. We have the speech synthesis. I have a demo page, which we'll see shortly. And then I have a control text to speech where you type in the thing. Then we have another one where you can choose the voices. And then you have another one where you can choose the language. And then you have another one where you can choose the slider for the pitch, another one for the slider for the rate, how fast you want it to talk, another slider for a control group, and that. So what I've seen is um, our our agent has basically generated components for each of those. It starts with the slider control, which is a slider, right? And it is the same as the slider that we have here, but you can see here we have a slider. Let me show you this slider that we have, the pitch slider, for example. So you see the type is range, ID speech slider. But instead of having multiple of them, you had another one, type is range, ID is rate slider. Another one, type is range, ID is volume slider. So we just have it here, and we have the IDs are now passing as parameters, the mean, the max. And all of this is embedded in something we call a slider control. So we don't need to put in all of this, including the CSS, right? The class name that was used, for all of this, right? It has done a bit of CSS as well, right? Picking from the original CSS that was done here, right? Um, Basically done that. And so I only need to pass in a few things and then event. But yeah, it has used that to generate the audio controls, the info box, right? The language selector, right? The slider control, the speak button, okay? Text input, okay? And the voice selector. So we have all of those components. So it's interesting that here I have the page. I can actually go to that page now. I go to synth and it's going to bring that up. Yeah, you know, since we're in run dev sometimes takes a bit of time to render pages. So it's rendering this page. Okay. One of the things that you find when you are using agents is you have to also understand the code, what they generated. So this is a code. This is basically a component version of it. Now the question is, does this work? So okay. Um, I will need to share my sound. So let me stop sharing the screen and reshare my screen with the sound. And just to demo to everyone how speech synthesis works and the kind of tweaking and controls that you can do. So if you can hear my sound, this is a default voice, right? It's not a very nice voice.
Hello, this is the speech synthesis demo.
Can you hear sound? Give me a thumbs up if you can hear the sound. Now let's choose. So this is a text. This is just some default text that I have in here. So now I can choose a voice. I have a good voice. The British voice here is pretty cool. Um, the way the code was written was so that when you choose the voice, the language will also adjust. So I choose Daniel, right? So when I choose Daniel, I'll keep the default values for pitch and speed and volume.
Hello, this is a speech synthesis demo.
So is what I type here that it's saying, right?
Hello, this is a speech synthesis demo.
Okay. Now you can play around with different voices here. So there are a whole bunch of them. There's a grammar US. I don't know if this works, right?
Hello, this is a speech synthesis demo.
So you see some of them still sound very robotic, right? But one thing I found is that the Google voices are really nice. Like go down to the Google voices, right? You have a Google Deutsch. This is a German voice. It takes a bit of time to
Hello,
compile.
this is a speech synthesis demo.
So it's a German voice with speaking English. This is an English Google voice, right? So you find some of the voices are really
Hello,
nice.
this is a speech synthesis demo.
Okay, so now let's go up. But you have a bunch of them too, like Albert. This doesn't sound very nice.
Hello,
I don't
this
know
is
why it
a
sounds like
speech
this on my
synthesis
computer, but
demo.
yeah, so at the end of the day, this allows you to play around. So what I plan to do with this now, which I'll do shortly, is to make this
Hello,
a,
this is a speech
s-
synthesis demo.
a set like a settings page where you can choose the voice and all the settings for your speech synthesis, right? That's the plan for this, right? But for now,
Hello, this is a speech synthesis demo.
okay. So so that page is done. As a matter of fact, since that page is done, I don't know why it is page page the synth.js exports from .synth.js. So it's exporting. So it didn't want to basically repeat stuff that is inside here. Instead, it re-exported. So what I would do, I will now ask the agent to clean it up. So I don't need to keep any of these things. So this is how you do agentic coding. Basically, you have to interact with the agent. You don't just a lot of people say, "Oh, just do this and go and sleep and take coffee." Me, I don't, right? So here I'm going to ask the agent. It seems this module is importing from synth.js in the parent class. I don't need that file there anymore. So you can merge the two of them and let the synth.js reside in app synth folder. Remove any duplicated code from and clean up, right? So I'll let it run this. Okay. Now, while it is running that, I still have recognition to do. I think I can delete the old page.tsx. Okay. Yeah. Well, okay. Let me just leave it in. Now, I haven't done the backend yet. So I want to start doing the backend because we are kind of running out of time. So the backend, I'm going to take the backend which I had already done um, from the lang chain example. Okay. By the way, I have a limit to the number of code spaces I can run at the same time. I think it's three or two. I can't remember. Um, so I have a lang serve example. I'm just going to take this lang serve example and use it, to make up my backend. So one easy way to do this, I can maybe just copy file by file, or I can pull it, I can clone it, right? So I think a good way to do that is to clone this, right? And to be honest, I really just need the scaffolding. Thank you. I only need the scaffolding, right? Um, and then I can code up stuff on my own, or I can ask the agent to code up stuff. I need the tool stuff. I need the rag stuff, or I can take the rag stuff from. Oh yeah, I did put the rag stuff in here. So as a matter of fact, I really don't even need to you know. I can just create a backend. So let me just create a backend here. Right. Okay, so it's done this, right? It wants to remove the one here, so it's asking for my permission. So again, this is irreversible. So it needs my approval before it goes ahead. Then there are some files that it changed here, which I can look at. Um, yeah, so it has changed the import, which is what I wanted. This is what I wanted. And yeah, I can just keep. Okay, then here the scene.js inside the scene.js, it has now added these other things, particularly say something, right? Which I think that's what is being imported um by the page component. The page component imports say something, all right, from scene.js. So yeah, say something. All right. Okay. So, yeah, we can just work with this. I don't need to clean this up anymore. The one thing I will do very soon is maybe later on, we can do that as an added thing is, yeah, this is gone, is how to um how I can use this synth now to set my speech synthesis parameters. I can ask the agent to do that. So for that, we'll need to introduce what we call a context in React, right? Where settings are stored. So I can just yeah, let me just create a context, a single file. I'm not going to overdo things. So I'm going to create a single file here and call it context because I don't want a very complex setup. Um, so let's do this. Um, or TS rather, it should be context.ts. Yeah. Well, I could also make it JS. So here I can ask the agent to I need a context where this voice synthesis settings are stored. Um this so whatever settings are stored are chosen in synth page.tsx are stored here. Also add a save button in the synth page.tsx to implement the the saving of to implement the saving of the settings. Okay, so let's agent do that. So while the agent is doing that, I can now I will create a new folder here, call it backend. That folder wasn't in the right spot, so I'll just move it up. I need it to be here. Yes, I need it to be here. Okay. So I have backend now. So I'm just going to take a few things from here. So the first thing is we have an app main, right, which is our main fast API entry point. So I'll just copy that and I'll come here and I'll create it here. So I'll call it app/main.py. Okay. So wait for that to get created and I'll paste that here. So these are fast API entry point for the backend. Yes, okay, so yeah, I can do this. So you can see how a lot of things are happening in parallel. The agent is running on its own. I am doing stuff on my own. And Pylance is installing itself on its own. So that's cool. Yeah, so let's go back to this. You see already it's beginning to implement that. It's always good to read all of this stuff, right? So that you are sure that this agent is doing what it's supposed to do. But I don't have a lot of time, so I'm basically doing a lot of things in parallel. So it creates a synth settings provider. use synth settings hook in the context TS, right? And wrap the app with the provider. So if you want, you can also persist saved settings in local storage. Yeah, so they can survive page refreshes. Yes, I can ask it to do that. Yeah, but for now, that's okay. Um, I don't know why this is a problem. I don't know why this is a problem. Um, sync settings context. Um, this is context value. This is context. Create context. Okay, created a context. Function sync settings provider. Oh, okay. I see the problem. So because we have added this thing, we should actually make this a TSX file. This is JSX. This is the JavaScript extended. We have, sorry, the yeah, well, Java, the React thing, right? We've included markup in here. So whenever you include markup, um, the um, the compiler or transpiler begins to get troubled. So we have to change this to a TSX file simply because of that. So once it knows that there is this in here, and it should be able to handle that properly. As a matter of fact, I would even have gone to the extent of doing a proper thing here, so that I don't have any problems, right? It helps me, view the things much easier. Yes. And yeah, so this should be this, right? Okay, so yeah. All right. So that is done. Let's even check again. So if we refresh, it should have added a save settings, okay? And it even has graded out. So it's when I change it, let's say I change the voice to Daniel now. Okay, I can now click on save settings. So okay, yeah, save settings should take us back to so let's do this. Save settings button should take us back to home page. Okay, yeah. So it's going to do that. So while it's doing that, let's continue with the Python bit. So we've added this. I need to add a requirements file so that I can do my installation. So I'm just going to pick that up from here. So I basically just copy the entire requirements um, and requirements.txt. Right. So paste that here. So I have all of this, right? And I may even have to set up a virtual environment immediately and change directory to backend. Okay, Python dash mv env. And then yes, even though this may not work exactly as I would like, but that's okay. Then source bnv bin activate, then pip install dash R requirements. So we'll install all the requirements. Where is requirements? Oh, okay, shouldn't be inside app. All right. Requirements.text. Okay. I already have a virtual environment, I just don't know about it. All right, so our stuff has done some changes. Let's go check out what the changes are. Um, no, not this is not what I'm looking for. So if you go to synth, you see how synth components JSX. So we now have a use router, which is cool. Router is use router, which is cool. Then router push. So after handle save settings, router push. That's cool, right? Okay, no problems. No problems. Okay, so Now here we have requirements of text. I need to add a git ignore as well. Um, yeah, we'll put our venv in the git ignore dot venv dot env. So we need to have environment variables as well. PyCatch, PYC, and so on. Right. Well, yeah, I'll never get enough of this, but that should be enough for now. So we have our main file, our app.main, right? And oh yeah, okay. So we have we now have get agent and get rag chain. So I'm going to just pull what we already have. I might improve the rag a bit later on. Um, so I'm just going to create this rag module rag.py. Okay. This is the same version I just shared, right? That has everything. Okay. Lang chain stuff and all of that. This will continue to be like this because the backend is not a top level folder. This is a problem that Pylance has, which unfortunately I cannot solve it. So I have the this rag, and then I have main. Um, where is app main? So we need to create so we have a route for the rag chain. Okay, we have a route for the rag chain. So I need to implement get rag chain, which will give us the rag chain. Um, as you can see, we already have a rag chain here, which has been created. But what I will do is um here what we did was we made it so I can run the rag directly. I'll still leave this in here, but I will now maybe refactor this. I can have the agent to do this, but let me do it myself. Get rag chain. And basically everything, well, okay, it's done this. So it's not self or get retriever. Oh, I'm sorry. Okay, self. Um, um, no, this should be on its own. So yes. So so I need to do a so I've added on the back end, I've added the agents, I've added the LLM, I've added the main, which we already did. I've added the RAG, and I've added the tools. Okay. So now we'll pull everything together. So first of all, we have .env, right? And we have fast API. we have lang serve, right? So lang serve will allow us to, um, of course, easily um, pull our stuff together. Then I have a rag. So we are just going to get the rag. We'll import from rag. We'll import the rag uploader. Um, so there it is, rag document uploader. So we are going to keep this instance of rag document uploader. So we'll create a single instance of it. So we can say uploader equals rag document uploader. Now we will have endpoint for uploading. So we had to get um endpoint, okay, and so um we have a rag chain which is uploaded or get rag chain. Um, so let's do this. We will create. So after creating the uploader, we'll upload documents. Okay. So here we are going to create a folder that we will store documents. Okay, so let's create a folder documents. Just a simple flat folder. We're not going to, so we'll have documents, right? And so upload documents, you can pass in from what we have done here. Um, we have upload batch. Load documents to load a single document, but it's part of the loop. Um, so what we should have is upload batch. So upload batch. So the way we will implement this is the batch will have a folder that contains it. So we are going to essentially get all the file paths in the list. Okay. In order to speed things up, the file paths. Okay. Okay, so now we can easily just get our file paths by specifying file paths equals lists dir. Okay, so let's get this from our path os dot list dir. Yeah, so we'll import os. This is in the in documents folder. Okay, so if you have any file in there, then that makes your file path. We create a fast API app. So we'll get the agent. I think we already have the agent set up here, right? Agent will get the tools. Okay. So to get the tools, one of the tools is search notes, and then the retrieval tool. So I hope there's not going to be some recursivity here, but let's just say from um rag. Okay, so I think we will in order to avoid secular imports, right? We will move this whole rag documents upload stuff, right? Um, sorry. this whole rag document upload stuff, we will move it into the uploader itself. So let's call it rag uploader. Even though that's probably not the best name, but we'll keep going. So rag uploader, after we have done the uploader, we will create an instance of the uploader here, right? And we'll get the file paths and we will upload everything in the file paths, right? Let me take this one out because this is not really part of the rag uploader. This is just a way to test which came from something we did before. So let me just call it test rag.py and I'll keep it there for now. All right. And we can fix the import from um rag import and then we'll import path. Yeah, okay. Okay. I don't know what else we have. Okay, we have a bunch of um yeah, let me just do this, ask the agent to do this. Fix anyway, I guess we can do it without having to use the agent. Chat OpenAI. So we can import this from LangChain OpenAI, import chat OpenAI from template, LangChain core. All right. Um, right. Really, we don't need all of this since we have already embedded this in the rag. Um, in the rag, we have get rag chain. So we have the chat OpenAI, we have the prompt template, and we have this, right? Where do we have format docs? Yeah, so if we have all of that here, this is just a repetition, which um so this whole section um chain we just do uploader dot get rag chain. That's all. So chain equals uploader get rag chain. All right. Well, this is not something we would really use, so we don't need all of this. We don't need path lib. Okay, yeah, so I think we need path lib. So it's used somewhere. Okay. All right. So this is just to get it out of the way so that we can focus on what is really doing the rag stuff. So we have uploader, rag document uploader, and we have file paths. So it's going to list this, and then from the file paths, we'll pass that in. Okay. So all the files that are in this documents folder will be uploaded up initially when this rag um, uploader is first imported. Okay. Then we will now use the rag uploader to get a rag chain. So then we will also get the agent, right? Agent, yes. So the agent is also going to use the rag uploader as well. So I think we can from app, yeah. So this should be in get tools. So when we are defining the tools, where we are defining the tools, we will upload it. Yes. Um, so here we will call the rag. So this first of all uploader um get rag chain. Okay. Then from rag import rag from app.rag import rag uploader. Then that's it. Okay. Messages. Message or rather message equals. So when you invoke a chain, okay. So this is something we need to test when the time comes. All right. So we have assembled hopefully all of the pieces. I can now ask my agent to clean up this code for me because right. Um so let's test the backend a little bit. We have agentic capability. We have main we have agentic capability and we can just um we can just run it, okay, and try out the different endpoints. So um let's be sure that we have all our requirements installed. Okay, okay. So now I will just run UVCon um app. Oh yeah, I forgot something. But yeah, I'll add it later. Main app.main app.main app reload. So this is on port 8000. Okay. So sentence transformers was not added to our requirements. So I am going to add it here. I'm surprised it is not here, but yeah, so let's add it here. We should have added it here. Um, so I can open another bash window. We'll go to backend pip VM bin activate pip installs requirements dash R requirements. So we make sure we install all the requirements. So hopefully sentence transformers will come in at the end. All right. So while that is going on, let's go back to our front end and just take a look. So what are we trying to achieve? Ask a question, you send the request to the backend, right? And then when the request returns, right, you speak out the response. That's the whole objectives. So far we have done our backend, we've done our front end. We've not really tested the backend yet. We just started testing and we found that we need to have sentence transformers in place. Then for the front end, we also haven't really tested it, right? We just have a chat interface and we'll see how it goes. So we finished testing the voice synthesis, okay, and I think we can go ahead and delete this synth module, this synth, because I think all the voices, uh, this synth does everything that um this other synth page does. So I can delete this now. Delete permanently. Okay. So now for recognition, we need to also run the voice recognition and test it. So again, I could do a bit of refactoring here, but let me ask the agent to also do this, right? So we can test voice recognition. So yes, convert this into a Next.js page at recog slash yeah. Okay, create components as needed, components and subcomponents. Reuse any existing components um, that are available. Okay, so all right. When it does that, we'll come back and test how our voice recognition works. As it is now, it does look like there is I may not have enough time to do everything. For some reason, this was terminated. Maybe it was taking too long, or maybe it was taking too much space. If I can't do sentence transformers, then maybe we'll have to look for other options. But let's hope that this second time it's downloading the whole of Torch, which is interesting. Torch is used for training models. Okay. All right. So it does look like oh, it's still terminated. Hmm. Okay. Yeah. Uh, Maybe we don't have enough space left. I don't know. So if I cannot do this with sentence transformers, maybe we'll have to look for another option. Maybe we use Pinecone. I don't know. But I'll come to that. As it is, let's go back to UVCon. So again, Torch, it gets terminated again. Gets to 914.1 and okay, it gets to 915.7. Okay, this time around it got to 915.7 and okay, that worked. Okay. We still have Torch, CUDA bindings, blast. Wow. So we have to get all of the NVIDIA stuff as well. I don't know if it's a GPU on this thing, but I don't know why we have to download all of this. Anyway, while that is going on, so we can take a look at what our agent did here. So it's converted the HTML file into Next.js page and main component with speech recognition logic and state management. So we are going to try out this speech recognition now, right? And let's see how that works. So, but let's look at what it did. Um, you have real-time speech recognition with interim and final result, multiple languages. So let's go look at that. So we now have recog. The components we have. So it still has all of this confidence meter, recognition controls, and all of that. And we have the page. Okay, so you see the keep button again. I'm going to keep this recognition controls. I'm going to keep this status display. I'm going to keep this, and we'll just see how it looks like when we run it. And these are the languages. Interestingly, these languages seems to have been duplicated. Um, yeah, but that's okay. All right. So, um, in the meantime, this is still installing. So let's go and look at how it looks like now. I'm going to refresh. I think we lost. Yeah, I have to restart it because we lost connection. So I have to run npm run dev again. Right. So there's one last bit which I need to do before this all comes together, connecting the front end to the back end. So I will need to create an API call, right, that will allow the front end to send requests to the back end, and then the back end will send a reply back. Okay, so to do that, we will use a standard um, Next.js API, call to do that. So um, we'll start off by going to the Next.js folder. Oh, by the way, this is back up. Let's check the ports. Okay. Um, it's not showing the ports in the list of ports, but it does look like we have access. So this is synth. Let's try recognition. So for recognition, it will need access to the microphone. So when I click on start listening, it's going to request access to the microphone. So I will accept that to give it access to my microphone. Okay, then I can say anything. Hello, I click on stop. It's when you click on stop that it will begin to do the recognition process. Okay, let's try again. Hello, can you hear me? Right. So you can see our transcript is following it. So our recognition is working out pretty fine, right? And this recognition is just using the built-in recognition from the browser. That's what it's using. And you can see how nice this is. Let me stop listening for now. Let's analyze. So it's not everything it's not perfect. Well, it's still listening even when I said stop. You see confidence level here. So try again, confidence 91. Hello, confidence 91. So some of them will have high level of confidence and some will have low level of confidence, right? I don't know why it's still listening. So there's a bug where it is still listening. Oh, okay, maybe I clicked it twice. Hello, hello. So it's a bit buggy, right? It's a bit buggy. It's a bit buggy. Yeah. The status here is not matching the internal thing. We can debug that. later on. Okay, so right. So we have speech synthesis done. We have speech recognition done. So now all we need to do is we have a say something function, which is what we'll use to call. Now in the speech recognition, I need a function. So we have recognition on results, right? And we have this. So the next thing I want to do is rather than, okay, maybe we can do that separately. Um, we have, I'll do this in a separate place, but you can see that the use effect is used here to just ensure that it continues to update itself. Okay. Um, Now to pull everything together, we will now go to the actual page here, and we have the main page component. Okay. We will add an API call. So to add an API call, we will create an API. Okay, so we are going to create a route that we will use to call basically a Next.js route. So in here, I'm going to create a Next.js route. I'm going to put it in API chat route.ts. So API chat route.ts. So in here is where remember we have API chat, then we have the page itself, and then we have components. So, but my structure is slightly different from what I kind of showed in my slide earlier. But yeah, we're just running it. So we remember when you use LangChain or LangServe to generate API calls, you get something like this. And we'll double check this, right? The endpoint is going to be somehow something like this, right? It's going to be something that looks like that. Okay. HTTP localhost 8000. We are going to use localhost because it's in the same server. So yeah. Now, so I'm just going to take the code for this. I'm not going to so this is send message, right? You specify the message you want to send. This should actually be on the page. So we should have a send message function. Okay. So you have a handle send message. So handle send message, enter the message, add message, set is sending true, show status connecting to backend, and so on. I will just embed it in here because here we have a message, then we are using streaming here. So I'm also going to show an example of using streaming. Right. So add message allows us to basically create what we call the conversation history. So we already have the messages here is already a list, right? It's a list of messages. Okay. So list of messages, um, yeah, backend URL, endpoint invoke. Endpoint should be agent/invoke, which is typically what we are seeing here. Then input field. As a matter of fact, maybe I will not bother about the routing. I'll just do a direct sending it directly. Yeah, let's just do that because that is already here and I'm kind of out of time. So we'll call HTTP localhost 8000. The endpoint is agent/invoke to call, or if you want to stream, it should be agent/stream. Yeah, let's use agent stream. So we get a streaming. Then the input field is input. So messages contains the history of the messages. So what happens is add message will add a new message with an ID, content, and role to the stack of messages. That's where you maintain the message history. Then update last message is basically update messages with a new message, maybe with a new message content. Handle update URL if you want to change the URL. So you can see if you look at the screen where we did this, right? Let's assume we go back. There's no back button yet, but yeah, if we go back to this, you see where I can update the backend URL. Okay. Okay. So when you are sending a message, once the message is typed, okay, add message, the message is added to the message list. Set is sending, show the status that is connecting to the back end. Then we put together the payload, right? Including the config, the input, which is the message. Then we build a full URL, okay? Then we run a fetch, okay, with this payload. The only thing I'm seeing here is this is not matching what we expect from langserve. Um, we are doing an agent API call. Okay, so create initial assistant message, handle streaming response. All right. So the full URL is going to take us to streaming. Since it is an agentic call, I'm not going to, we don't need to do all of this. We can keep the conversation history for the agentic call itself, but the actual conversation that we're currently having, we are keeping it here. So we stream the response, right? So the approach to streaming is you create a text decoder, full response accumulated text. So you keep reading. And I think I showed this before. This is how you stream. You keep reading. When it is done, you break. But while it is ongoing, you put the full response, pass JSON line if the backend sends this. Then the other thing is once lines are completed, so this is basically it keeps pulling chunks together. Once the chunk is done, right? You now look at the response format. If it is a string, right? You just put the data. But if it is data output and it is string, then you stringify. That is JSON. So if it's data output, we assume it is JSON. So basically, this handles different response formats, and then you update the message. So And then after streaming, so the beauty of this is that it allows you to continue printing the message as it is um, it is previous. So what this does basically is that it keeps updating the messages as it is streaming in. And then when it is all done, this is when it is all done, it basically handles the remaining one and updates it finally. So this whole thing has the complete thing, right? The one thing I want to add here is that after it has completed, we should go ahead to speak the whole message, right? So we can speak after completion. Okay, so you can just say we go back to our synthesis. We have our synthesis here. We're not doing it from scratch. Agent thinks we're doing it from scratch, but we're just importing synthesis from synth.js. So we'll just import synthesis from synth.js and we run it. That's all. Um, say something. The options should be the options were in the context. So we can get um we'll use synth settings to get the synth settings. So let's go here. Page, we have to do the imports. So we will import, yeah, we'll import say something, but it's not from dot slash synth, slash synth. Yep, that's the correct thing. Okay. Then we will import use yeah. Okay, so you got that as well. Um do we have okay. Oh yeah. Page synth. Okay. Um then use settings. Right. So in the component we will from the use synth settings, which is the context, we will get um we will get value. We'll get value, which is the saved settings. Okay, then when we get value, um, I don't know why it's called value. I'll prefer to call it settings. Well, let's leave it in like that. Okay, so we're almost there. We're almost there. Um, yep. Oh, okay. I think I understand now. So you have saved settings and save settings. Right. Okay. So um the accumulated text is out of scope, but yeah, updates last message. Full response. So it's somewhat outside of the scope. Let's see. I think yeah. Um, okay. Yeah. All right. So that's the correct place to place it. Okay. So I think we can pull everything together. Our message sending is okay. We won't use speech recognition. We don't have enough time. We'll just send the message as it is from here. And so let's try something like hello, and we send again hello, and we send. Okay, so we have a bunch of errors. Let's check. Connection refused. Right. So of course, I haven't yet set up the back end. So let's set up the back end. Um, yeah, but at least that proves the front end is okay. So let's go set up the back end, which is the UV coin. I'm just going to run it. I think all the sentence transformers are installed now. Um, so we can just run UVCon, main app dot main colon app and reload. Okay, so we now have 8,000. Um, we can actually check this 8,000 to see if we have anything coming in. We probably don't have, but let's see. Our agent seems to be okay. Sentence transformer, list dir document. So this was our rag basically, and it says there's no directory called this, so we need to fix that. So let's go to backend. Of course, we're still testing the backend. We have not yet fully fixed it. Um, so this will be in our rag. Oh, we're setting it up. Um, we could use path. Um, it's going to, well, let me just ask the agent to fix this. Sometimes I do that. Fix the file paths. We actually have to get the base, something like, well, I probably don't, I can do this. So we just do something like this. Yeah, nope, that's not correct. Import um from from path from os.path import base name dir name. Yeah. Okay, so um we already have from I think we already have pathlib imported. Yeah, so we can just do this dir name um or rather we typically can do this dir name file, okay, or we could do path dot pro absolute path dot absolute yeah, so file base path file directory or document directory equals that so let's use pathlib. Okay, then file paths um os.lists dir. All right, so we don't need these ones anymore. Okay. uh, Relative to okay, I can print this just to be sure. Print yeah. Let's see. Um oh, this is what we should have actually done. Yeah, that's what I should have done. AppRag is not in the subpath. Okay. So maybe that was the problem. URL backend is not a subpart of documents. Oh, okay. You have to go up. Right. Um, parent. So you have to go up. Um, yeah. Okay. Okay, so we have to go up two steps. Parent, app documents. Right, cannot import name rag uploader. So we've gone past that one. We now have a new problem, which is easier to, okay. So we have uploader as, well, we can just call it uploader. That's okay. Um, rag uploader. Let's find rag uploader. I now have it here as well. So it's going to be a problem here as well. Okay. Okay, so we are good now with this, but we now need to add the environment variables at the backend that will give us access. So dot env, um, let's we'll add let's see what the environment variables that are needed. We need we need for RAG we need several of them. We need OpenAI API key, Pinecone API key. Well, we're not really using Pinecone, so I just need OpenAI API key. Um, then for agents, we don't have any. Um, for LLM, it's still OpenAI API key. Okay, so I will just create that. But in this case, I am using OpenRouter, so I'll just get the OpenRouter API key that I already have, and we will use that. Okay, yeah. All right. It looks like things uploader get rag chain, type and weight. So I also forgot that. Yeah, so we need to pass the type, but we can just use some default values as well. So the type, let's use hybrid, and the weights. Yeah, so let's just um so first of all, I need to check that the rag rag has been built. So if not self vector store, um we will just build it self dot um build vector store. Right. That's all. Okay, let's try something now. So we still have, perhaps I am not connecting to the right. Let's check our network tab. Stream. Okay, so there's no document in documents, and that may be the problem. So since I don't have upload set up, right, let me just upload a few documents here. Let me just upload a few documents and then we can. So let's see. I need a few random, maybe PDF documents. Okay, it's interesting. Okay. Right. So I do have a document here. Attention is all you need. So I'm just going to drag this document and upload it um into my um yeah, we don't have enough time to test everything, so I cannot test the upload function, but let me just manually drag a document in here. So, right, so this is a PDF document, right? It contains what we call the attention is all you need paper, which is now I need to rebuild this. Um, okay. So this time around, um, I keep seeing this error which says unexpected embeddings, position IDs. Okay, uploading documents from this, right? Skipped this. Attention is all you need. File not found. Attention is all you need. PDF. No documents to index. Please add documents. So there is a problem here. It finds the file and then it says file not found. So there is a problem. Let me see what that problem is. Okay. Um, because it first of all says skipped file not found, right? Which doesn't make sense to me because how would it know if the file was not found? So I think something is missing. Let's just debug it a bit. Let's just debug debug it a bit. Okay, so it's reloading. Let's see if it is actually so uploading documents from this, loading documents, loading document. Okay, so it's just a file name. That's the problem. Um, yeah, it's just a file name, not the full file path. Okay, but um, so the load document has a bit of a problem. Um, I could ask the agent to do this, but it's going to take too long. So upload an index. Um, Upload an index. Okay. Um, Upload batch. Okay, so I think the problem is that we do upload batch, so it actually does that. But we're not getting the full path. So this is a problem. Print. Yeah, this is where the problem is. Let's see. Found files. So found files. So it's really just a file name, which is what we are trying to ask it to upload. Yeah, and that doesn't work. Meanwhile, we have uploading documents from this. So the issue we have is base path is this. So yeah. Um yeah, AI is picking this up already. Base path um is a string or a path. Okay, let's put it this way. Union string or path, and default value should be none. Okay, so I need to import union from typing and base base path. And then we can see if well, I don't know what happens if you do this, right? So I'll just let it run and see what goes wrong. Okay, so this time we have this files found, loading documents, right? Documents that PyPDF package not found. Okay, so now we have a problem with PyPDF. Okay, so all the dependencies I forgot to install. Yeah, let's add this to the requirements. I thought I had that already. PyPDF2, PyPDF. Okay, that's interesting. Um, right. So I think for the first time that our installation completed without any problem. So I hope everything is cool now, and we should be good. So loading this file, we still have a problem. Could not import ChromaDB Python package. Okay, so we need to add ChromaDB as well. I had files, I had Pinecone, I forgot ChromaDB. All right. So incomplete implementation. Okay. Let's install everything again. I'm always doing this just to be sure. I know I could have just installed only ChromaDB, but it's just to be sure that the requirements text is complete. Um, right. So ChromaDB is in now. So the other thing with ChromaDB is, do we need to run the server separately or not? But we'll see how that goes. So we'll just run UVcorn. Okay. So it's ingesting the single file. We only have a single file in there. Right, so we've successfully finished ingesting or added 93 documents. So these 93 documents and lang service up and running, very good. So the 93 documents we have are actually chunks from this single document, right? Attention is all you need. 93 chunks created. These 93 chunks become the 93 lang chain documents that are indexed. We now have a ChromaDB that is created, and ChromaDB is you have the information stored there somewhere. And then a vector store is built with 93 documents. BM25 retriever is also built with 93 documents. Batch upload complete. Okay. I just printed this API key. I don't really need to do that. Um, I don't really need to do that. So okay, then Lang service up and running. We have agent playground, we have rack playground, and we have a bunch of other things. So our agent is live, right? It's on. This agent stream should be working now. So let's just try and see what happens. Okay. So this is still failing. So let's see what I need to do. Lang serve is running, but port um I don't know what port. Port 8000 is not up. So um it seems something is still not complete. But UVcorn is running. UVcorn is running on 8000. I don't see it here. I don't know what port 5248 is. Let's just check what we have in port. Um, AI backend running. So port 8000 is running. Yeah, but it seems we don't have access to it. So what I will do is change this to be oh yeah, I guess it's not running locally. It's running from the browser. So we oh yeah, so almost there, almost there. The port is not showing through. So um we will actually need to yeah, we'll have a bunch of course errors as well. Let's see. I didn't set up course here. We need to set up course for Fast API. We'll not even have access to it. Okay, so let's see if we can fix this. Set up with to allow from all origins. Okay. So port 8000, maybe it's getting blocked or something. I don't know, but it's not coming through. So let's change it and use a different port. I think I've had that problem before where port 8000 was not allowed. So let's use a different port. Port is 8998. Let's use that. So if we're using port 8998, this should come up and we can change this to 8998. And then we're not going to use, well, maybe we should use the URL that is given, the forwarded URL, but it's not coming through here. It was coming through before, but it's not coming through anymore. Let's remove reload and we just run Ubicon without reload. So now just getting the backend to come through so that we can connect to that. That is the problem now. And port is not being forwarded. 8998. Okay, maybe there's a way I can forward the port. Um, oh yeah, okay, now it's forwarded. It's just not displaying it for me to see. This is it. So that's working. So that's what I would use here. And update. Yeah, so I'm getting that And if I even put slash docs, I'm going to get lang serve, the whole thing. And I'm going to get agents. I think we have agent slash stream. So we have agents slash stream, which is what we are using. So all right. We can now say hello and let's see what we get here. Okay, so now we have a course problem. It's now a course problem. And considering that I had already fixed the course problem, I'm surprised that it's kind of, let's see. Um, yeah, um, I had specified allow origins to allow all origins. So I'm surprised. Allow credentials, allow methods, allow headers. So that should be okay. Maybe I need to restart. Well, I know I have restarted after those changes, but just to be sure, um, course error. Hmm. Okay, let's switch the NPM to start mode. So NPM run build. Okay. So maybe it's in dev mode, so I don't know. I'll switch it to production mode and we'll see how that goes. So right now this goes away. Fail to compile. Okay. Um, I didn't use this anymore, so let's just delete it. I had intended to use it as an extra TypeScript route, but it's taking, we already run out of time, so it's taking too long. Okay, npm run start. So we have this, and we have the port, and it's 3000 and it's public. So I can refresh it and replace this with that update. Update. Hello. We still have a course error. So I think I'll have to go fix this. If I were to do this with Postman, we would probably detail method not allowed. Um, okay, let's say we try. Yeah. So I believe a lot of these restrictions are really because I am running this on because I'm running this on Code Spaces. So Code Spaces has a lot of restrictions. I would have thought that I should just be able to access this, but there's obviously another course restriction that is not due to Fast API, right? So I'm not even able to do that. So what I would do is I am going to run this locally on my computer and show you how it will run um, using, I'm going to run it locally and I'm going to share my VS Code so you can see how it works. But basically, that is it. We have essentially completed the hands-on, but let's make it work. So with this, I am going to let's update the git ignore here. I'm not sure if I had a git ignore here. Okay. So we have PyCache, um, documents. So I'm not going to include the documents. VMs. I think we had VM already. We had VM already. We have .env. Okay, so git add front end. Okay. So this is basically an entire um Next.js app, then git add backend. Okay, let's commit it separate. Added front end folder, then git add backend. Okay, and I think everything is cool as well. So git commit. So you see how small the backend is. All right, so I can push this. So I'm now going to switch to VS Code and we will see, we will run this on VS Code and see how well it does on VS Code. So to do that, I'll open a new um, VS Code window and I'm going to let me share my VS Code window with you. Okay. Um, so I'm going to clone a Git repository, clone from GitHub. UI lab, good. And I'm just going to put it in my projects folder. Um, yep. Um, okay. Yeah. So cloned the repo. So we now have backend front end here on that. Yeah, we need to set up all the requirements quickly. So same GitHub, same VS Code interface. Um, so I'll go to the back end first, and I need to create a .env. Then I need to create a virtual environment, Python. I'm going to use 3.12 -mv env.venv. And so while this is running out, I'm also going to do the front end. So I typically use pnpm, so I'm going to just run pnpm install to install all the dependencies. Okay, back end, I'm going to source the back end, activate, and I'm also going to install pip install requirements. So that's going to install everything. PNPM is also installing. No space left on device. Wow. Okay, so I need to create some space. That's interesting. Um, okay. Yeah, I think I got back some space. So I thought I already had sentence transformers installed.